Throughout the course, we're going to learn how to use NMAP in detail to scan the networks. NMAP, Network Mapper, is a free and open source utility for network discovery and security auditing. Many systems and network administrators also find it useful for tasks such as network inventory, managing service upgrade schedules, and monitoring host or service uptime. NMAP runs on all major computer operating systems, and official binary packages are available for Linux, Windows, and Mac OS X. NMAP has been used to scan huge networks of literally hundreds of thousands of machines. NMAP is usually very good at documentation. Significant effort has been put into comprehensive and up-to-date man pages, white papers, tutorials, and even a whole book. You can visit nmap.org to find out more about NMAP. While NMAP comes with no warranty, it is well supported by a vibrant community of developers and users. It's one of the most well-known tools of the network security domain, and indeed, with a lot of facilities, it's very powerful. In addition to the classic command line NMAP executable, the NMAP suite includes an advanced GUI and results viewer, ZenMap, a flexible data transfer, redirection, and debugging tool, NCAT, a utility for comparing scan results, NDiff, and a packet generation and response analysis tool, NPing. NMAP uses raw IP packets in novel ways to determine what hosts are available on the network, which ports of these hosts are accessible, what services those hosts are offering, what operating systems are running, what type of packet, filters, firewalls are in use, and dozens of other characteristics. Beyond all this, NMAP has its own scripting engine and allows developers to develop new modules. In the following lectures, to discover the network, we'll perform the following with NMAP. First, we'll use ping scan to find out the hosts in the network. Then we'll use different types of port scan to find the open or accessible ports. We'll detect the services running on the ports and their versions. We'll try to learn the operating systems running on the systems. And after that, we'll see how to use scripts with NMAP scans. And we'll learn some important scripts as well. NMAP sends some packets to discover the network. To prevent security devices from blocking our packets, here's where we're going to learn some timing tricks. Then we'll see what we can do more of to bypass security devices such as packet filters, IDS, or IPS. Here, there's an NMAP command example. Let's see some basic parameters of the NMAP command. NMAP is, of course, the command itself. S is to define the scan type. If you use S with uppercase T, as seen in the slide, it means you want to run a TCP scan. We'll see the important scan types in detail. If you don't use this parameter and you have the administrator privileges on the computer where you're using NMAP, SYNSCAN is a default scan type. If you don't have the admin privileges on the computer, TCP scan will run. Destination IP address is the only required parameter to run this command. It means you can run the NMAP command like nmap 172.16.99.139. This is the IP address of the target machine which you want to scan. You can either give a single IP address or give an IP block or an IP range as a target, but we'll see that soon. Destination ports are the port numbers that you want to scan. If the target port numbers are not given to the command, top 1,000 ports will be scanned. Be careful, I didn't say the first 1,000 ports. I said the top 1,000 ports. That means the most used 1,000 ports will be scanned. There are different ways to enter destination ports, and we'll see them in detail. Let's do the first scan. So now let's write our first NMAP command. So with this command, we will scan the IP of the Kali Linux computer. So for this, just open Kali Linux, username root, password tour, and click terminal. Learn IP with ifconfig, NMAP, and your target IP, press the enter key. All right, so here we've entered our own IP information as the target IP. So how can we find other threads and other targets? So this is where we should probably talk a little bit about IP and network concepts. We briefly mentioned the concept of a rope before, but let's go into a little more detail. So these concepts are the basic concepts that you can probably encounter in just about all of your penetration testing. Might sound a little boring at first, but I really do want to help you master this subject, right? So we got to talk about what is a network. Yeah, I know we've already defined network in that network, but let's dive a little deeper, shall we? So it's a communication system that devices establish with each other in a certain area. Information and system resources are shared among different users. And data can also be transferred from one location to another. And a network is formed just by connecting at least two devices. Now, on the OSI reference model, it's located on layer 3. So what is the OSI reference model? So if you haven't ever encountered it before, the OSI, or Open Systems Interconnection, is a model that was developed in 1984 by ISO, which is the International Organization for Standardization. Now, before you purchased a computer system prior to an OSI standard, everything from cable to a network card, drives to network operating systems were custom made for that company. Therefore, different devices could not communicate effectively with each other. So that's why this model quickly became widely accepted and also became a guide for network standards. So that way, devices manufactured by different companies with the OSI standard will basically be able to communicate using the same protocols. Now, the OSI model consists of 7 different layers. And here they are. Layer 7, application. Layer 6, presentation. Layer 5, session. Layer 4, transport. Layer 3, network. Layer 2, data link. And layer 1, physical. So for now, we'll leave these layers here, though throughout the course we will discuss OSI additions when we get to them in related topics. Now, getting back to the NMAP scan that we perform, it will occur on the network layer, which is OSI layer 3. Now, so with a scan, NMAP will try out the first 1,000 TCP ports that are most commonly used, which ports are available, and what their status is, whether it's on or off, and then the service names that will be using those ports. The 1,000 TCP ports used by NMAP will come by default, and if we want to change the list of ports used, we just need to modify the file user share NMAP services. I don't recommend that, though. Interpretation of NMAP results. So when we run the NMAP command, we can have all the information about all of the results and the scan. Incoming results include port information, port status, open or closed, service name, cause information, etc. And the results of the NMAP scan are interpreted and then processed in the next step. For example, according to port information, you can plan your attack types and how they relate to your specific target. So for this example, a ping scan was performed on the IP address 10.0.2.4, and the results are listed here. And additional lines will be listed according to the type of scan performed. Let's say if the operating system parameter was entered, we would see the results in the rows that specify operating system of the target IP. So in the lessons that follow here, we're going to do some very relevant examples, but you are now familiar with the overview. We'll be looking at results in detail, specifically the target IP, which will display the IP address that is being scanned. Number of coded ports, NMAP scans 1,000 TCP ports by default, unless otherwise specified. So you can specify how many of the 1,000 ports are closed as a result of scanning. And ports found shows the ports that are used or in use, and they are open on the destination after scanning. Port state displays a status of the ports found, whether they're on or off. Service name displays the service names that are used on the found ports. And for a service state reason, why the ports are open or closed. And the MAC address displays the MAC address of the target threat. Scanning specific IPs or specific targets with NMAP. So the goal of scanning with NMAP should be to get the best information about the target as quickly and efficiently as possible. Therefore, it may only be necessary to scan on specific targets. So NMAP offers a very flexible number of possibilities. Let's have a look at some of them. So in our previous example, we saw how to scan a particular subnet, right? The NMAP subnet command. So scanning an entire network will take some time, depending on the number of devices in the network. Scanning an entire subnet can also cause security systems to be on alert because it's attempting to access many different threads from a single source thread, a computer thread that is used for scanning. So this, of course, can be recognized by security systems, and then the IP address that you're using for scanning will be blocked. So instead, we only scan specific threads. So to use this command, you need to know the target IP information in advance. So the command we will use is nmap IP1, IP2, IP3. So here, IP1, IP2, and IP3 are the IP information of the target systems. And the number of IPs written here can be increased. NMAP, command, and list creation. So we've already seen that certain IPs can be scanned with the command nmap IP1, IP2, IP3, right? So similarly, instead of typing these IPs in a single screen, we can write them to a file and scan from line to line with nmap. So this gives us an enormous amount of flexibility when scanning. So the file can be IP, subnet, or web address. They can be all found together or individually. So let's open up these virtual machines that we created. And we'll remember the IP addresses of the virtual machines. So Metasploitable IP is 10.0.2.4. Ubuntu IP is 10.0.2.7. Windows 10.0.2.6. Kali Linux is 10.0.2.15. Good, so now the file can be created as follows. So log into Kali Linux, username root, password tour, click terminal, and type leafpad/root/desktop/test.txt and enter. So we want to scan for IP, subnet, or enter a web address. However, you've got to pay attention to this. Each value will be written on a single line. So here we'll save the file, and we'll write the command nmap-il/root/desktop/test.txt and enter. As you can see, nmap reads from the file and then executes a scan. NMAP random scan and exclude IPs. So with NMAP, you can scan any number of random targets on a network. Right? To do this, simply type nmap-ir and a host number. So this penetration test can be used to set random targets and make discoveries related to these targets. So log into Kali Linux, open terminal. So for example, let's scan just 50 targets randomly. NMAP 10.0.2.3/24-IR 50, press enter. And as you can see, only 50 IPs were scanned. So with NMAP, you can scan specific targets or exclude specific targets from scanning. So this command will be able to save us time by excluding known targets from scanning, as well as knowing if there's a firewall on it, or we can scan by excluding the IPs of security servers. So we can open the virtual machines that we created. And of course, remembering the IP addresses of the virtual machines, Metasploitable IP 10.0.2.4, Ubuntu 10.0.2.7, Windows 7, 10.0.2.6, Kali Linux 10.0.2.15, so we'll log into Kali Linux, open up Terminal, and Nmap 10.0.2.0/24-exclude 10.0.2.6, 10.0.2.7. Press Enter. And as you can see, the excluded IPs were not scanned. So we can write the threads required for this process one by one, or write them into a file and run Nmap reading from this file. So the Nmap exclude file command should be read from the file in order to specify the unwanted target. So let's open the virtual machines that we created. Now we can log into Kali Linux, open Terminal, and type Nmap 10.0.2.0/24 exclude file /root/desktop/exclude list.txt and press Enter. And there's the example file, 10.0.2.6 and 10.0.2.7. As you can see, the excluded IPs were not scanned. Print the Nmap results to the file. So a few lectures ago, we saw how we identify which ports are scanned. Now in Input Management, we'll see how we identify which systems are scanned. Okay, go to Kali and open a terminal window. First, I'll prepare an Nmap query, and because I'll play with the destination IPs, it will be the last parameter of my query. Nmap is the command itself. N to close the name resolution, uppercase PN to close ping, uppercase S for SYNSCAN. Now to keep it simple, let's scan just the top 3 ports. Now is the time to identify the destination systems. Up to now, we learned to scan a single IP, and we learned how to scan an entire C block, 0 through 24. Okay, so what are the other ways of identifying target systems? You can select a range of any part of the IP address. In the slide, the third and the fourth parts of the IP address is given as ranges. That means Nmap will scan IPs from 192.168.1.0 to 192.168.255.255. I'd like to keep the range small. I'll only define a range for the fourth part of the destination address from 100 to 150. There's only one machine between 172.16.99.100 and 172.16.99.150. You can scan more than one IP block in a single query. The example in the slide scans 2 ranges. The first range is between 192.168.1.0 and 192.168.1.255, and the second range is between 10.0.0.0 and 10.0.255.255. Since I don't have a second network on my Kali, I continue with the third example. The third example is the combination of defining a range and a single number. For example, you can scan the IPs between 100 and 140, IP 206, and the IPs between 220 and 230. So here are the results. Nmap found a machine from the range of 100 through 140, the machine with IP 206, and another machine from the range of 220 through 230. Another way to define the target systems is to give Nmap the IP addresses in a file. In a typical penetration test or ethical hacking, you will scan the network a lot of times. First, you find the hosts. It doesn't make sense to scan the entire network again and again. You'll see huge networks, so if you scan the entire network each time, the pen test will take a lot longer than you think. Let's open a second terminal screen and find the hosts of our IP block using PingScan. As we learned before, now clarify the output to have only the IP addresses of live hosts. grep command to get only the rows containing IP addresses. And cut command to get only the IP addresses from a row. Now we can redirect the output into a text file to reuse the list in following queries. But first, let me close the name resolution. Now, put a greater than character and give a file name to write the result, iplist.txt. We're not interested in the first two IP addresses, so let's edit the file and delete them. I use Nano Text Editor to edit the file. In Nano, use Ctrl-K to delete a line. Use Ctrl-X to exit Nano, press Y to save changes, and hit Enter to save on the same file. Type cat iplist.txt to look at the file again. Now we have 4 IP addresses in the file. Let's create a new NMAP query, and this time, let's give the destination systems in a file, iplist.txt. And here are the results of the 4 systems which are listed in the iplist.txt file. So let's talk about the output management in NMAP now. Up to now, we've run a lot of NMAP queries and got the results on the terminal screen. This is the default output behavior called interactive output, and it is sent to standard output, std out. In a penetration test, we should save the results of the queries to be able to analyze them later on. Hopefully, NMAP has its own output management skills. So let's have a look. There are 3 major output saving formats in NMAP. Normal output, which is similar to interactive output. That's what you see on the screen up to now, except that it displays less runtime information and warning, since it is expected to be analyzed after the scan completes rather than interactively. Greppable output, which includes most information for a target host on a single line, so you can use it to collect the information you want using the excellent grep command. We've already seen a few examples of grep command in this course. XML output is one of the most important output types, as it can be converted to HTML easily parsed by programs such as NMAP graphical user interfaces or imported into databases. There is one more magic parameter, which is O_A, to let you generate the outputs in all formats. Now let's see the NMAP output management in action. Go to Kali and open a terminal screen. Prepare an NMAP query. For this example, I want to prepare a SYN scan. Now we're ready for output management options. First, I want to generate the XML output using O_X parameter. O_X parameter needs the output file name. You can give the file name with the full path. If you don't specify a path, just as in this example, the file is created in the current folder. Be careful. OX, OG, and ON parameters require the full file name. So if you want the file to have an extension such as .xml, you should specify it here. Hit Enter to run the command. To see the generated file, here it is. And use the less command to see the content of the file. So it's typical XML file with tags. Here's a host tag, starts and ends. All the results about a host is listed between the start tag and the end tag. IP address, scan ports, and of course, the scan results. Here is another host tag and the scan results of the second host as well. Press Q to quit, less command. Now let's call back our NMAP query with the up-down arrow keys of the keyboard. Now I want to generate all types of outputs. Type O_A and the base name of the files. Be careful, O_A parameter requires the base file name of the files, not the full names of the files, and it'll put the file extensions itself. Let's look at the content of .nmap file using the less Linux command. This is almost the same as you'll see on the screen. Now let's look at the greppable output. Here there are two lines for each host, one to show the status of the host and another one to show the port scan results. So what is a port and how does it work? Well, in computer networks, hardware connections are terminated physically, wired or wireless. In software, a port within an operating system is a logical structure that identifies software-specific process or service. The ports are identified by 16-bit long numbers of each protocol and address combination. The most common protocols that use port numbers are the Transmission Control Protocol, TCP, and the User Datagram Protocol, UDP. Now, the port number is always associated with a host IP address and its communication protocol type. Completes the destination or source network address of a message. And then certain port numbers are used for specific services. For example, port 80 is used by HTTP. Port 443 is used by HTTPS protocol. So then this way the package can be easily transmitted to the running application. The most commonly used ports are ports 1 through 1024, and other ports can be specified to a particular application. The most used default ports. So below are the most commonly used default ports and the names of the services that use them. Now, it's important to remember these ports, know them well, is because we can understand what the systems are in the target network when we're scanning. So according to the port scan results, we can plan the next step. Or if there are services that we know are used within the target network, we can scan directly for these services and then finish the scanning process without getting caught in the security systems. So if port 21 is open, FTP service is available. And if port 53 is open, DNS service is available. If port 110 is open, there is an SMTP service, which means that mail service is up and running. FTP is 21, SSH 22, Telnet is always 23, SMTP 25, DNS UDP 53, HTTP 80, POP3 110, NetBIOS 139, IMAP 143, SNP UDP 161, SMB Microsoft DS UDP 445, RSH 514, VMware 902, MS SQL 1433, Oracle DB 1521, MySQL 3306, RDP 3389, VNC 5900, Proxy Application Servers 8080 and 8081. 25, scanning the top 20 and the top 100 ports with NMAP. So I'll remind you, in our very first scan with NMAP, all we did was enter NMAP IP address. Now, since we didn't enter any port parameters in that particular IP scan, by default, NMAP scanned the top TCP 1000. So in this way, it may be reasonable to scan for a single rope. However, it will not make sense to scan the entire network. So therefore, wouldn't it be a good idea to scan only specific ports when we want to scan? So in this way, we can scan faster and reduce the chance of, catching the attention of security systems. NMAP offers many alternatives for scanning specific ports, so let's have a look at the most used types of them one by one. So if we type the command nmap -- top ports 20 and a destination IP in the terminal, NMAP will search for the top 20 TCP ports on the target system. Now you have to remember that NMAP always performs a TCP port scan if no specific parameters specified. So if you want to see what these 20 TCP ports are, we can write nmap -- top ports 20 VOG. V parameter means verbose. The OG parameter specifies that the scan result will be in greppable mode. So we're only going to see displayed the last dash parameter. Similarly, if you want to see the top 100 ports, we can write nmap -- top ports 100 VOG. And similarly, if you want to see the top 1,000 ports, we can write nmap VOG. And we can do the same thing by adding TCP parameters. So what I mean by that, we write nmap st -- top ports 20 VOG. So st is the parameter. That's the TCP port. Then similarly, if you want to see the top 100 ports, we write nmap st top ports 100 VOG. And then if we want to see the top 1,000 ports, we can write nmap st VOG. So let's do an example here. Open up VirtualBox, open Kali Linux, and open Metasploitable. Log into Kali Linux VMs, and open up Terminal, and write this command, nmap 10.0.2.4 st top ports 20 VOG, and press enter. Now, if we only want to see the port numbers, nmap st top ports 20 VOG, and press enter. And if you want to see what these 20 UDP ports are, we can write nmap su top ports 20 VOG. Now here, the SU parameter is the UDP port, and the V parameter is verbose. The OG parameter specifies that the scan result will be in greppable mode, so it specifies that what will be displayed as the last parameter. So similarly, if you want to see the top 100 ports, we'll write nmap su top ports 100 VOG. And if you want to see the top 1,000 ports, we'll write nmap su VOG. So we can go back and open VirtualBox, open Kali Linux, open Metasploitable, and log in to Kali Linux VMs. We can open Terminal and write the command nmap 10.0.2.4 su top ports 20 VOG, press enter. And if we only want to see the port numbers, nmap su top ports 20 VOG, and press enter. Scanning specific ports with nmap. nmap p ports and target IP. So you don't want to scan just the top 20, the top 100, or the top 1,000 ports with nmap. Instead, we can set the ports that we want to scan. So this way we can scan faster and way more specifically. Now, unless otherwise stated, our scans will be valid for these TCP ports. If we want to perform a UDP port scan, we'll need to specify it on the command line. Remember, in our previous lesson, we saw how to do this. So to perform a UDP port scan, we need to use the SU parameter in the command line. For example, let's scan some of the TCP and UDP ports on our Metasploitable VMs that we've already set up. So we can perform the most commonly used TCP 80 HTTP port and TCP 443 HTTPS port and UDP 53, which is the DNS port, scans in sequence. Okay? So open VirtualBox, open Kali Linux, open Metasploitable, and log into Kali Linux VMs. Open Terminal and write the command nmap 10.0.2.4 P53 80 443. Press enter. And the scan results appear. So let's have a look. So it shows the TCP 80 and 443 ports. Now, since we didn't enter the UDP parameter, the UDP port did not scan. So let's do a UDP port scan and have a look. NMAP SU P53 80 443, press enter. And here you can see TCP does not show ports 80 and 443 since we enter the UDP parameter. Only the UDP port shows up as a scan result. Now, both TCP and UDP port scanning can be performed at the same time. So when you want to do that, you write this into the command line, nmap STSU P53 80 443, and press enter. And there you have it. Both TCP and UDP ports show up in the port scan results. Scanning a specific port range with NMAP. Now, what was the port before? So we learned what it's used for, but there are 65,535 port numbers in most computer systems. So with NMAP, we can scan a wide range of ports, right? So this method can be used if the scan results, based on the default port numbers, are negative. So this means that well-known services are always targeted. Hackers often give priority to scanning these ports, like obv. So in this case, by changing the number of these ports, maybe an attack can be prevented. So because many hackers use ready-made attack systems, they're always going to scan the default ports. So for this reason, the security level can be increased just by changing the port number of a service used within the application. For example, port number 443 HTTPS can be changed to 14443. So in this case, attacks to the HTTP service will be prevented. NMAP also allows you to scan specific port ranges for these such situations. So for this, NMAP port P, port number, and press enter. Now, please make a note that unless you specify otherwise, our scans will be valid for the TCP ports. And if we want to perform a UDP port scan, we just need to specify it on the command line. In our previous lesson, I believe we saw how to do this. To perform a UDP port scan, we just need to use the SU parameter in the command line. So let's do an example. We'll scan for specific TCP and UDP ports on the Metasploitable VMs that we've already set up. So open up VirtualBox, open Kali Linux, open Metasploitable, and log into the Kali Linux VMs. Open terminal and write this command, nmap 10.0.2.4 p 1000-2000. Press enter. And the scan results come up. So here you can see it scanned the TCP 1000 to TCP 2000 port range, and it shows the results. Now, both TCP and UDP scanning, of course, can be performed at the same time. When you want to do that, you just put this on the command line, nmap STSU P 1000 to 2000, and press enter. And there you have the scan results of the TCP and UDP ports between 1000 and 2000. SYN scanning. NMAP SS target IP command is the most commonly used form of scanning in NMAP. Of course, if we do not give a parameter while scanning, NMAP will always scan TCP. So the scan uses the aforementioned three-way handshake system. A SYN scan is faster and less detectable than a TCP scan because in this scan the connection is terminated before it's fully established. However, you should also remember that they may be detected by next-generation firewalls and security software. I'll show you how the scan works. So step 1, NMAP will send a SYN packet to the scanned port of the target computer. Step 2, the computer receiving this response will send a SYN ACK. Step 3, after receiving this answer, NMAP does not send the ACK packet from the computer that we're scanning to complete the connection. Instead, it sends a reset packet. So that way the possibility of logging is reduced and our speed increases as there is not a full connection. Now, this type of scan is especially useful for systems that use firewalls. That way the status of the corresponding port of the target is determined. In SYN scanning, comments are made according to the answers received. So when a SYN scan is performed, the following answers can be received from the target system. The port open status. So NMAP sends a SYN packet to the destination, and the destination system sends the SYN ACK packet. NMAP terminates the connection by sending a reset packet instead of sending an ACK packet. And that indicates that the port is open and accessible, and that the port accepts a TCP or UDP connection. Port closed status. NMAP sends the SYN packet to the destination, and the destination system sends a reset message instead of the SYN ACK packet, and then terminates the connection. And in this case, the port is accessible but cannot be processed. Now, how about the port filtered status? So, two kinds of answers can be received here on the NMAP side. First, the NMAP sends a SYN packet to the target system, and no response is received from the target system. When that happens, it is not commented whether the port on the target system is open or closed. Then secondly, NMAP sends a SYN packet to the target system, and the destination system sends the ICMP unreachable error packet. So then in this case, the port is accessible, but it's not known whether it's open or closed. TCP scan. So in our previous lessons, we discussed the TCP scan, and by default, NMAP always performs TCP scans unless otherwise specified. So let's take a closer look at a TCP scan with NMAP. NMAP sends a SYN packet to the target system, and the target system receives the packet and sends the SYN ACK packet to the NMAP computer, which receives an NMAP packet and sends the ACK packet to complete the connection. The destination system port sends the port information that is open. NMAP terminates the connection by sending a reset packet immediately. So to scan TCP with NMAP, we need to add the ST parameter to the NMAP command. So I'll give you an example. We'll scan the TCP top 20 on the Metasploitable server that we installed. So open VirtualBox, open Kali Linux, open Metasploitable, and log into Kali Linux VMs. Now open up Terminal and write the command nmap 10.0.2.4 top ports 20, press enter. And the results of the scan are right here. So let's have a look. As you can see, the top 20 ports were scanned, and it lists the results. TCP and SYN scan difference. So yeah, okay. So what are the differences between the SYN scan and the TCP scan? They're right here. A SYN scan, three-way handshake, does not complete. The TCP scan, the three-way handshake, is complete. The SYN scan, if the SYN ACK packet arrives, the connection is terminated with reset. And on a TCP scan, if the SYNAC packet arrives, the connection is completed with the ACK packet. In a SYN scans are usually not logged on the server. TCP scan are logged on the server. SYN scans require root authority because there was interference in the packages. A TCP scan does not require any root privileges because it uses the TCP connect method. UDP scan. So in our previous lessons, we discussed the UDP scan. Most of the services that are popular in server systems run over TCP protocol, however. UDP services are also widely used. So DNS port 53, SNMP ports 161 and 162, and DHCP port 67 and 68 are the most commonly used services. UDP scanning is generally slower and is more difficult than TCP scanning. So for this reason, some security controllers kind of ignore these ports. Extensible UDP services are common. Therefore, this is an error because attackers do not ignore the entire protocol. So in order to scan UDP with NMAP, we will need to add the SU parameter to the NMAP command. And it can be combined with a TCP scan type, just as the SYN scan as S, to control both protocols using the same scan. Sound good? A UDP scan works by sending a UDP packet to each targeted port. And for most ports, this packet will be empty. That means no load. But a protocol-specific data payload will be sent for several of the more common ports. Now, 4 different situations can occur when we scan UDP with NMAP. And these will be open status. That's when NMAP sends a UDP packet to the target system. And if the UDP response is sent from the destination system, that means that the destination port is open. And a closed status. So NMAP sends a UDP packet to the target system, and if the ICMP port from the destination system sends an unreachable error response, that just means that the destination port is closed. An operation cannot be performed. Filtered status. NMAP sends a UDP packet to the target system, and if the ICMP sends unreachable errors from the target system, the destination port is filtered. So the port is open, but it cannot be operated. It's likely that security software is being audited by it. Open filtered condition. NMAP sends a UDP packet to the target system, and if there's no response from the target system for a certain period, NMAP accepts this port as open filtered. So that just means it cannot decide whether the port is open or closed, but still an operation cannot be performed. So now let's do a simple UDP scan. So here's the example. We'll do a UDP top 10 port scan on the Metasploitable server we installed. So we open VirtualBox, open Kali Linux, open Metasploitable, and log in a Kali Linux VM, and open up Terminal and write this command, nmap 10.0.2.4 su top ports 10 reason sv, and press enter. And there are your scan results. So as you can see, the time is too long for the TCP scan. NMAP UDP scanned the top 10 ports and listed the results. Up to now, we have seen the most important scanning types to discover a network. There are some other scanning techniques in NMAP which are not used as much as the others, but in some cases, you may need to find some other ways to be able to discover the sensitive hosts in a network. In this slide, we'll see 3 more scan types: null, fin, and Christmas scans. The common ground of these 3 scanning methods, null, fin, and Christmas scans, is that they send packets to the target systems in which SYN, ACK, and wrist flags are not set. Null scan, S_N, does not set any bits. That is, the TCP flag header is 0. Fin scan, S_F, sets just the TCP fin bit. Christmas scan, S_X, sets the fin, push, and urge flags, lighting the packet up like a Christmas tree. There are 2 rules defined in RFC standards about such packets. The first rule is, if the destination port state is closed, an incoming segment not containing a wrist causes a wrist to be sent in response. The second rule is, packets sent to open ports without the SYN, wrist, or ACK bits set are dropped. These 3 scan types are exactly the same in behavior except for the TCP flag set in probe packets. If a wrist packet is received, the port is considered closed, while no response means it is open or filtered. If an ICMP unreachable error, type 3, code 0, 1, 2, 3, 9, 10, or 13 is received, the port is marked as filtered. So as a result, with these types of scans, you can find out if a port is closed or not. It's not possible to understand if it's open or filtered if there's no response. This scan is different than the others discussed so far in that it never determines open or even open filtered ports. It's used to map out firewall rule sets, determining whether they are stateful or not and which ports are filtered. The ACK scan probe packet has only the ACK flag set. When scanning unfiltered systems, open and closed ports will both return a wrist packet. NMAP then labels them as unfiltered, meaning that they are reachable by the ACK packet, but whether or not they're open or closed is undetermined. Ports that don't respond or send certain ICMP error messages back, type 3, code 0, 1, 2, 3, 9, 10, or 13, are labeled filtered. So in this lesson, we will see how we can discover the online hosts in the network using the ARP ping scanning method. So one of the most common NMAP usage scenarios is to scan an Ethernet LAN, right? There are multiple ways to discover hosts in your network, and one of these methods is the ARP ping scanning method. Well, okay, so what is ARP anyway? Address Resolution Protocol. It's a low-level protocol that works at the link layer level of the OSI model, which was explained in the NMAP OSI model lesson. So the link layer is a protocol that's used in IP version 4 local networks to discover online hosts in the local network. It can't be used on the internet, right? So when using NMAP on a network, ARP protocol is applied by default because, well, it's just faster and way more reliable. All right, so how does ARP ping scanning work? ARP ping scanning works in a pretty simple way, actually. A regular ARP packet request looks for the MAC address using the device's IP address. NMAP sends ARP requests to the destination IP addresses, and if a host responds with an ARP reply, that means a host is online. NMAP uses the -PR parameter for ARP discovery. So let's go ahead and try this. So open Kali Linux in VirtualBox. Enter username, password, and open terminal. So first, we've got to learn our IP address because we're going to need them to learn which IP range that we're going to look for the live hosts in. So write sudo su- for root permissions. Enter the root password. And write ifconfig enter the terminal. Okay, so here's our IP address. Now we know which IP range we will look at, right? So let's write NMAP, and the -SP option tells NMAP to only perform a ping scan, then print out the available hosts that respond to the scan. This is also known as a ping scan. And write -PR for the ARP discovery. Then after writing those commands, we'll need to specify the IP ranges. We can specify the range like writing /24. That's at the end of the IP address, or we can just put the asterisk at the end of the IP address. Cool, so here are the live hosts in the local network. Like I said earlier, the ARP scan is set to be the default network ping scan in NMAP. If you just scan the network with the -SP parameter, you can see which protocol NMAP uses as the default protocol. So to see this, write -- packet trace with -SP. So see that's a double dash packet with a dash, just a single dash in between? All right. Anyway, as you can see, the ARP protocol is used by default. Now, if you don't want to use the ARP protocol, you've got to write -- disable-ARP. All right, so let's see this. Write NMAP -- packet -trace -SP space -- disable -ARP -ping, and the IP range that NMAP is going to look for. So press enter. Okay, so as you can see, NMAP is making ICMP echo requests for searching live hosts. What do you think? So we've learned what the ARP is and how we can use it. All right, so in this lesson, we are going to see how we can discover the online hosts using the ICMP ping scanning method. So, of course, there are multiple ways to discover hosts that are up and running, and one of these methods is the ICMP ping scanning method. ICMP, or Internet Control Message Protocol, creates a feedback mechanism by working in the data part of the IP packet at the Internet layer, and then reporting on the problems to the communicating units. So it's part of the IP protocol suite. Therefore, it is in layer, say it with me, layer 3. So ICMP is a protocol that helps TCP/IP to work, provides feedback by the host in case of error. So ICMP protocol will run on every host. Hence, ICMP echo requests are blocked, even through simple firewalls. ICMP is also used for checking live systems. Ping is the most well-known utility that uses ICMP requests, and the principle is pretty simple. ICMP scanning sends requests to hosts and then waits for an echo request to check and see whether the system is alive. An ICMP ping scan can have 3 parameters. One of them is -PE. So this parameter makes ICMP echo requests. The other 2 parameters are timestamp reply, -PP, and address mark reply, -PM. These parameters could bypass misconfigured firewalls, which only block ICMP echo requests. All right, so let's try and send ICMP echo requests to the target IP. Open up Kali Linux and VirtualBox. Enter username and password. Open up terminal. Enter sudo su dash, and that gives you root permissions. Enter the root password. write NMAP -SP. So this option tells NMAP to only perform a ping scan, then print out the available hosts that respond to the scan. And this is indeed also known as a ping scan. -PE for making ICMP echo requests and the target IP address, as seen in the terminal host, right? So for you to see, again, just write the same things and we'll add --packet-trace. Now press enter. What do you see? NMAP is sending ICMP echo request packets and returns taking ICMP echo replies. All right, so that's how we can discover the hosts with ICMP pings. NMAP fast scanning. NMAP F target. So in this lesson, we will see the quick scan parameter with NMAP. Of course, in our previous lessons, we've indicated that if NMAP port range is not specified, TCP will scan the first 1,000 ports. Now, when you scan with the NMAP F parameter, the top 100 ports will be scanned. So let's open up VirtualBox and Kali Linux. Open up Metasploit 10.0.2.4. Log into Kali Linux VMs. Username root, password tour. Open terminal and write this command. NMAP 10.0.2.4 F V top ports 10 reason. And there are the scan results. And that's the top 100 ports. And there's the list. NMAP open port scanning. NMAP target IP command open. So in scanning ports with NMAP, NMAP will scan and list all of the ports that you specify, whatever you desire. Now, it will also be able to specify whether the port is open or closed when it lists your results. So if we want to see only the open ports, we can use the NMAP command open res parameter. So in this case, it only lists the ports that are open after the scan. It does not list the status of the other ports. So for example, scan the top ports on the Metasploitable server and list just the open ports. So for this, let's open VirtualBox, open Kali Linux, open Metasploitable, log into Kali Linux VM, username root, password tour, and open up the terminal. So write this command, NMAP 10.0.2.4, top ports 10, open, press enter, and there are the scan results. And the ports that are open are listed here. NMAP no port scan. So of course, NMAP is a program that's used to perform active scans. And the discovery of the results will help you set your goals for what your pen test will be. It's going to be unnecessary to scan all the ports for each IP, especially when scanning large networks. So instead, wouldn't it be quick and logical to detect open computers as a first step and then only scan for ports on those computers? Yeah, so let's do this then. NMAP can perform a ping scan just to detect the computers that are turned on. So scanning with SN consists of an ICMP echo request, TCP SYN to port 443, TCP ACK to port 80, and an ICMP timestamp request by default. Now, only SYN packets are sent to ports 80 and 443 on the destination by a non-privileged user. So let me show you an example. So let's make an active discovery on the network where the virtual computers are that we have established. So for this, let's open all of the virtual computers that we have installed. Open VirtualBox. Open Kali Linux 10.0.2.15. Open Metasploitable 10.0.2.4. Open Ubuntu 10.0.2.7. Open Windows 7 10.0.2.6. Now log into Kali Linux VMs. Username, root, password, tour. Open up terminal and write this command: nmap sn 10.0.2.0/24 and press enter. Okay, so here are the scan results, and we can see the computers that are open here. NMAP ping scan. NMAP SP target. So this scan type lists the host in the specified range that will respond to a ping. It allows you to determine which computers are online rather than which ports are open. So basically there are 4 methods in NMAP for ping scanning. It will send an ICMP echo request packet to the target system. And if an ICMP echo reply is received, then the system turns on and ICMP packets are not blocked. If there is no response to the ICMP ping, NMAP attempts a TCP ping to determine whether ICMP is blocked or whether the host is actually online. The TCP ping sends a SYN or ACK packet to any port on the remote system, and of course the default is 80. If reset or a SYN ACK is returned, the remote system will go online. And if the remote system does not respond, it is offline or the selected port is filtered and then therefore does not respond to anything. So when you run an NMAP ping scan as root, the default will be to use the ICMP and ACK methods. However, this method may not work correctly on all networks, especially where ping packets are prohibited. Let me show you an example. So we'll make an active discovery on the network where the virtual computers are that we have established. So for this, let's open all of the virtual computers that we have installed. Open VirtualBox. Open Kali Linux 10.0.2.15. Open Metasploitable 10.0.2.4. Open Ubuntu 10.0.2.7. Open Windows 7 10.0.2.6. And then log into Kali Linux VMs. Username root, password tour. Open terminal and write this command: nmap sp 10.0.2.0/24. Press enter. And the scan results appear. And we can see that the computers are open right here. NMAP no ping scanning. So if you scan with the NMAP PN parameter, it accepts that the target threads are open, scans all the ports for each IP without pinging. So it could take a long time to detect master servers, especially in large networks. Use NMAP PN target. NMAP V command. So if the V parameter is used for NMAP scanning, the detailed results are listed. And if the V parameter is used twice, the results can be more detailed. NMAP target V V. So I'll show you an example. Let's scan the top 10 ports on the Metasploitable virtual machine. And let's see the difference in the meter. And as you can see, it only lists port names and numbers, the port state, whether they're open or closed, and the service names. Now we'll do the same operation with the V parameter. NMAP 10.0.2.4, top ports 10V, and press enter. And there's the different scan results. So as you can see, you get more details and in the list. Now, if we do the same operation twice by putting the V parameter in, let's see how that works. NMAP 10.0.2.4, top ports 10V, V, press enter. And there are your scan results. Indeed, we have much more detail in the list. So for this, open VirtualBox, open Kali Linux, 10.0.2.15, open Metasploitable, 10.0.2.4, log into Kali Linux, username root, password tour, open terminal, and write this command, NMAP 10.0.2.4, top ports 10, press enter. Now the scan results follow. Indeed, we have much more detail in the list. In those NMAP lectures, we have seen no port scan, also known as ping scan, different ways of scanning ports, SYN scan, also known as half-open scanning, TCP scan, also known as TCP Connect scan, and UDP scan. Now let's see some more details to be able to use NMAP more effectively. We have found the hosts and open ports of them. Now is the time to find out the services which are listening to those ports and the version of those services. In addition, let's detect the operating systems running on those systems. Suppose that you ran an NMAP query and it told you that ports 25 TCP, 80 TCP, and 53 UDP are open. Using its NMAP services database of about, 2,200 well-known services, NMAP would report that those ports probably correspond to a mail server, SMTP, web server, HTTP, and name server, DNS, respectively. This lookup is usually accurate. The vast majority of daemons listening on TCP port 25 are in fact mail servers. However, you should not bet your security on this. People can and do run services on strange ports. Even if NMAP is right, and the hypothetical server above is running SMTP, HTTP, and DNS servers, that is not a lot of information. When doing vulnerability assessments, or even simple network inventories of your companies or clients, you really want to know which mail and DNS servers and versions are running. Having an accurate version number helps dramatically in determining which exploits a server is vulnerable to. And version detection helps you obtain this information. After TCP and/or UDP ports are discovered using one of the other scan methods, version detection interrogates those ports to determine more about what is actually running. The NMAP Service Probes database contains probes for querying various services and match expressions to recognize and parse responses. NMAP tries to determine the service protocol, for example, FTP, SSH, Telnet, HTTP. The application name could be ISC bind, Apache HTTPD, Solaris Telnet-D. The version number, host name, device type, something like a printer or a router, and the OS family, you know what that is, Windows, Linux, etc. So let's see how to use service and version detection in NMAP and why it's important. Okay, go to Kali and open a new terminal window. Let's create the NMAP scan command. NMAP is the command itself. N is to avoid the DNS resolution. Uppercase PN is to avoid the host discovery. I'm using the SYN scan this time. I write the destination IP, which is the IP address of my Metasploitable VM, and the destination ports, the top 10 ports. Let's run this command first to see the results of a command without version detection. Now, I open a new terminal window to create a new NMAP command. I prepared the command with the same configuration. SYNSCAN, Metasploitable, and top 10 ports. I add S_V parameter for version detection and hit Enter. As you see, the query takes longer this time. The SYNSCAN without the version detection took less than a second, and the SYNSCAN with version detection took about 12 seconds. In the first query, service names are estimated by NMAP according to the default services running on those ports. In the second query, on the other hand, NMAP probed the ports to determine more about what is actually running. Now, I want to show you the most important reason of using version detection in NMAP queries. In Kali, I'm going to run SSH on port 443 and then scan the port with NMAP. Let's perform the demo together. First, look at the listening services if SSH is running. Netstat, TNLP. SSH is running on port 22 at the moment. Type service SSH stop to stop SSH service and hit Enter. Now, to change the port of SSH, we're going to change the configuration. Open the sshd_config file with a text editor to change it. I use Nano text editor for this purpose. Type nano/etc/ssh/sshd_config and hit Enter. Find the port line, delete the sharp to make it a valid configuration line. The sharp was used to make it a comment line. Change the port number to 443. Control-X to exit Nano, Y to save changes, and hit Enter to save over the existing file. Start SSH again using the service SSH start command. Look at the listening ports to double-check Netstat TNLP. SSH service is running on port 443 now. Let's scan port 443 of Kali with NMAP. Prepare the NMAP SYNSCAN command. No version detection for this query. NMAP detects that the port is open. Look at the service. NMAP says the service is HTTPS. Using its NMAP services database, NMAP reported that this port probably corresponds to a web server for HTTPS, and we know that's not true. So let's prepare the NMAP SYNSCAN again, but this time use S_V parameter to run the version detection mechanism. Now, as you see, port 443 is running and the service is SSH, not HTTPS. Version detection interrogated the port to determine more about what is actually running. NMAP queried the port using the probes of the NMAP service probes database and matched expressions to recognize and parse responses. And the version of SSH is OpenSSH version 7.6p1. So, if you are not 100% sure about the type of the running service on a port, run version detection. Got it? Good. So one of NMAP's best-known features is remote OS detection using TCP/IP stack fingerprinting. NMAP sends a series of TCP and UDP packets to the remote host and examines practically every bit of the responses. After performing dozens of tests, such as TCP/ISN sampling, TCP option support and ordering, IP/ID sampling, and the initial window size check, NMAP compares the results to its NMAP OS-DB database of more than 2,600 known OS fingerprints and prints out the OS details if there's a match. Each fingerprint includes a free-form textual description of the OS and a classification which provides the vendor name, for example, Sun, underlying OS, that would be Solaris, OS generation, let's say 10, and device type, general purpose, router, switch, game console, whatever. OS detection is far more effective if at least one open and one closed TCP port are found. So let's see the OS detection in action. We have to use OS detection with one of the port detection techniques. So I use SYNSCAN for this demo. The target system is Metasploitable. Let's choose top 100 ports to make the query faster, or just don't give any port. Let the NMAP scan top 1,000 ports. That won't take long. Put uppercase O for OS detection and hit Enter. Here is a result of OS detection. It's a general-purpose device and running Linux with a version between 2.6.9 and 2.6.33. If you would like NMAP to be more aggressive to have a more accurate result, you can use OS scan guess parameter with OS detection parameter. Now, let's scan a Windows system and try to find out the version of the OS. So here I have a Windows 8 virtual machine. I want to learn its IP address first. Open a command prompt, type ipconfig, and hit Enter. Now let's go to Kali and test if we can reach the Windows system. First, I'll ping the system. No, the system is not responding to the ping requests, or we cannot reach the system. So second, I perform an NMAP ping scan. We know how to do it, right? Type nmap sn 172.16.99.171 and hit Enter. Yes, nmap says the host is up. So we are able to reach the system. Now I want to scan the top 10 TCP ports of the system. I add the reason parameter to see the reasons of the results. All the ports we scanned are filtered because there are no responses from them. It's not good for us. So I add the OS detection to the latest nmap query and rerun it. No, nmap cannot find the OS details because it does not have a result set to probe or interrogate. I would like to open a port on the Windows system and reply the nmap scans. In Windows 8 VM, I run the IIS, Internet Information Services Manager, and start to host the default website of IIS. Open a web browser and try to reach the website typing the IP address of the system into the address bar. Okay, web service is up. Let's test if I can reach the website from Kali. I go to Kali, open a browser, enter the IP address of the Windows 8 VM, and hit Enter. No, I cannot, and I think I know the reason. In Windows VM, let's look at the firewall if HTTP traffic is allowed. So I open the firewall. At the upper left corner, I click Allow an app or feature through Windows Firewall link. Click Change Settings, which needs to have admin privileges. Go to the end of the list. As I thought, HTTP services are not allowed. Check it and click OK to apply the changes. Now in a command prompt to see port 80, I run netstat an command. When I come back to Kali, I see that the page is loaded in the browser. That means Kali can reach port 80 of my Windows 8 VM. Now in Terminal Screen, I want to run SYNSCAN for the Windows system's top 10 ports. Here we have an open port now. So let's reply the scan with OS detection option. Now we have the OS detection result. First, NMAP warns us about the results. It says the results may be unreliable because it couldn't find a closed port to probe. But anyway, NMAP makes it best. And here it says the operating system is one of them. Windows 2008, Windows 8.1, Windows 7, Windows Phone, or Windows Vista. Good job. NMAP Script Engine, or NSE. So what do you suppose script scanning would be? So NMAP is indeed a software for port scanning purposes, right? It can also be used for pen test purposes using its advanced features. NMAP has started to be developed as a port scanning tool, and today it has exceeded itself with its vulnerability and exploitation features. So the NMAP scripting engine, or NSE, is one of NMAP's more powerful and flexible features. So it allows users to write and share simple scripts to automate a wide range of network scanning tasks. These scripts are then executed in parallel with the speed and efficiency that we would expect from NMAP. So users can use scripts distributed with NMAP or write themselves to meet their specific needs. NSE consists of scripts in these following categories: defined categories, auth, broadcast, brute, default, discovery, DOS, exploit, external, fuzzer, intrusive, malware, safe, version, and vuln. So the category names are not case sensitive. And, well, let me just briefly describe each category. Auth. So these scripts handle authentication information, or bypasses it, on the target system. Instead of scripts that use brute force attacks to identify credentials, they are placed in this brute category. Broadcast. Scripts in this category typically discover hosts that are not listed on the command line by publishing to the local network. Use the new target script variable to allow these scripts to automatically add hosts that they discover to the NMAP scan queue. Brute. So these scripts use brute force attacks to estimate the authentication information of a remote server. NMAP, HTTP brute, Oracle brute, SNMP brute, etc., including many scripts that enforce the protocol. Discovery. These scripts attempt to discover more about the network by querying global records, SNMP-enabled devices, directory services, and so on and so forth. So, DOS. Scripts in this category can cause denial of service. Sometimes it is done to test the vulnerability for denial of service method, but more generally, it is undesirable because of the side effect required to test a conventional vulnerability. In other words, these tests sometimes crash sensitive services. Exploit. These scripts are intended to actively exploit a vulnerability. External. Scripts in this category can send data to a third-party database or another network resource. For example, WhoisIP establishes a connection to the Whois servers to obtain information about the destination's address. The operators of the third-party database probably record everything that comes into them. So this will log your IP address and the destination address. Most scripts that do not fall into this category contain absolute traffic between the scanning computer and the client. Fuzzer. Scripts in this category are designed to send unexpected or random fields by the server software in each package. Although the technique is useful for finding undiscovered errors and vulnerabilities in software, it runs both slowly and uses a lot of bandwidth. An example of a script in this category is DNS fuzz, which slightly bombs a DNS server with incorrect domain requests until the server crashes or a user-defined time limit expires. Intrusive. These scripts cannot be classified into a secure category because the risks may be high enough to destroy the target system. It can fully exploit the resources, that means bandwidth, CPU, RAM, of the target system. Therefore, they are perceived as unwanted processes by system administrators, as you may very well imagine. Malware. These scripts test whether the target platform is affected by malware or backdoors. For example, SMTP strange port, which monitors SMTP servers running on unusual port numbers, and authspoof, which identifies similar fraud numbers that give a fake answer before receiving a query. Both of these behaviors are usually caused by malware infection. Safe. Scripts that are not designed to crash services, use large amounts of bandwidth or other resources, or exploit vulnerabilities. They're less likely to harm remote administrators, but we cannot guarantee that they will never cause adverse reactions, as with other NMAP features. So most of them are performing general network discovery. Scripts in this category are not classified for security, but all other unsafe scripts should be placed as intrusive. Version. So scripts in this particular category are an extension of the version detection feature and cannot be explicitly selected. They're selected to run only when version detection, SV, is requested. The outputs are indistinguishable from version detection output and do not generate service or host script results. Vuln. These scripts check for specific known vulnerabilities and typically report results only if they are found. Default. So this is used with SC or the A parameter. Scripts defined in the default category are speed, usefulness, verbosity, reliability, intrusiveness, privacy. Script equals can be used with a default parameter. So NMAP script files in the scripts folder. If you don't know the folder name, you can list all the scripts when you run locate NSE on the command line. If you're looking for a specific script for a specific topic, then just type it into the command line. If you want to, you can always edit the scripts. You can review them, make changes. For example, if we are looking for DNS-related scripts, we just need to type in the command line Current NSE scripts are available at nmap.org. You can view all scripts and usage patterns at this address, nmap.org, NSE doc. So NMAP, since NSE is open source, it's constantly updated. Therefore, it is necessary to update the script database before scanning with scripts, yeah? So to do this, you just run the command, script update. Now there are a few parameters to scan the script with NMAP. And I'll show you a few of them. NMAP SC. If we only use the SC parameter, NMAP scans for each IP and port with scripts defined in the default category. NMAP script, script name, target. So in this case, NMAP will scan with the specified script. So if you want to get help with a script, we can use NMAP script help script name. NMAP scripts can be used with other parameters as well. So the script that we use here must be compatible with the service that we scan. Might not seem obvious, but... So let's write a few examples of NMAP commands. Example 1. So let's do a script scan related to HTTP. First, we'll do a port 80 scan on the current network. So we'll turn on virtual machines that we have installed, open VirtualBox, open Kali Linux 10.0.2.15, open Metasploitable 10.0.2.4, open Ubuntu 10.0.2.7, open Windows 7 10.0.2.6, and log in to Kali Linux VMs. Username root, password tour, open terminal, and write this command. NMAP 10.0.2.0/24 P80, press enter. Okay, so here are the scan results. And one of the machines that we found is Metasploitable 10.0.2.4. So let's check out what scripts we have. So go to the command line, locate *.nse pipe grep HTTP. And let's look at the results. So we can scan all of these scripts by using them, or you can use them one by one. So in this example, let's run an HTTP brute scan. On the command line, enter NMAP 10.0.2.4 script HTTP brute and press enter. So if we want to look at what is in the script, we can write leafpad user share nmap scripts http brute.nse. Then when we open the script file, we can see all of the commands used and the explanations put in by the person who wrote the script. And if you want to get just about half, then just type nmap crypt script help http brute.nse and press enter. So here you can review it by clicking on the link on the Internet NSE doc. The scan results will be listed as follows. Now, if we want to crawl using all the scripts related to HTTP, go to the command line, nmap 10.0.2.4 script http *, press enter. But I'll be honest with you, this command can take a long time to run because NMAP will try all of the HTTP scripts in sequence. So in this example, let's do a script scan on the Ubuntu VM using the default and safe categories. Now to get help on the default and safe scripts, at the command line, type nmap script help default and safe, press enter. And the help information related to each script will be listed. So we can turn on the virtual machines that we have installed, open VirtualBox, open Ubuntu 10.0.2.7, open Kali 10.0.2.15, log into Kali Linux VMs, username root, password tour, open terminal, and write this command at the command line, nmap 10.0.2.7 script default and safe. Press enter. There's your scan results.
All right, so in this lesson, we're going to learn how we can do a brute force attack just by using the scripts. So brute force attacks, this is a type of attack that's based on, well, basically trial and error, right? This attack commonly uses automated tools to guess various combinations of usernames and passwords until they finally find the correct input. NMAP has multiple scripts about brute. If we list out the scripts, you can see NMAP has multiple scripts that vary from technology to technology. So in this lesson, what we're going to do is use MySQL brute, SSH brute, and FTP brute scripts, and we'll test the Metasploitable 2 machine. You ready to try these scripts? So first, run the Metasploitable 2 machine, open Kali Linux and VirtualBox, enter username and password, open terminal, enter sudo sudo- for root permissions, enter the root password. Cool, so let's start with the first script, which is the MySQL brute script. Right, nmap -p3306. That way you can specify the port address, --script for choosing the script MySQL-brute, and the target IP address. Now, brute force may take some time, so while it's doing its thing, let me see some arguments that come with the script. So for seeing the arguments, write nmap and the script name into your search engine, and nmap has a document for each script on the official nmap website. And as you can see on the screen, nmap gives us the arguments and the output of the script. If we look at the script output, what you're looking at is the script showing us the username and password for MySQL access. The second script is SSH brute. So we can write in the terminal nmap -p22 for specifying the port address, --script for choosing the script SSH-brute, and the target IP address. Cool, so the script immediately starts to try to find the username and password. Why don't we have a look at the arguments that belong to this script? So what you see on the screen are the arguments of the script, and here is the example usage. So the script shows the username and password for SSH authentication. Whew. So the third script, it's FTP brute. Write nmap -p21 to specify the port address, --script for choosing the script FTP brute, and the target IP address. And the script starts to try to find that username and password. Why don't we have a look at the arguments that belong to the script? Okay, so what you're looking at are the arguments of the script, and here's the example usage. So the script shows us the username and password for FTP login. All right, that's everything you need to know about how to use brute scripts.
NMAP timing templates. So in scanning on these networks, our goal, of course, is to make discoveries as soon as possible without being noticed. And this discovery identifies to us the computers and ports that may be open. This next step is to obtain the necessary information. Now, our biggest obstacle when scanning, of course, is security systems. But NMAP offers different alternatives for scanning without being caught in security systems. They are activated by the T parameter and named in the range 0 to 5. So the T parameter is only related to timing when it's used with other parameters. T0 paranoid. Only one port is scanned at a time, and it's used to send packets very slowly. The time difference between the two packets sent is 5 minutes. So this option is one of the modes used to bypass security systems. T1, sneaky. So this mode is used when you want to send packets quickly, but it's still slower than a normal scan. The time difference between two packets sent is 15 seconds. Of course, this option will be the second mode that's used to bypass security systems. T2, polite. So in this mode, you'll be sending packets quickly, well, more quickly than T0 and T1, but certainly slower than a normal scan. So the time difference between the two packets sent is 0.4 of a second, and when scanning in this mode, you may be visible to security systems. T3 is our normal operation, so this mode is the default NMAP timing pattern used when the T parameter is not specified. So yeah, what is the time difference between the two packets sent? Is 0.1 of a second. T4, aggressive. You will use this mode when you want to send packets very quickly, and NMAP will wait only 1.25 seconds for a response. So the time difference between the two packets sent is up to 10 milliseconds. Now, the official documentation of NMAP recommends the use of T4 for modern, reasonably modern, and reliable networks. T5, or insane. So use this mode to just send insanely fast packets, and it'll only wait 0.3 of a second for an NMAP response. And the time difference between two packets sent is up to 5 milliseconds. So, of course, this mode makes scanning super fast, but sometimes you're going to sacrifice accuracy. So if it fails to complete a scan within 15 minutes, NMAP will give up a host. Otherwise, the T5 should only be used on a fast network and high-quality systems, because sending packets that fast can affect the operation of the network or the entire system and can even cause system failure. Bypass of IPS and IDS systems with NMAP. So what is IPS and IDS? With the development of network systems, security problems have arisen exponentially. The network system can attack the computers. Unauthorized persons may attempt to access computers. The outgoing packets over the network can be viewed by third parties and saved and viewed on their own computer. Critical systems running over the network can then be rendered inoperable and face many security problems. That's why they're called vulnerabilities. So in order to prevent these security problems, systems that constantly monitor the network and prevent future attacks are deployed. So these such systems are called IPS, or Intrusion Prevention Systems, and IDS, or Intrusion Detection Systems. So today there are many very advanced IPS and IDS systems. With the development of the Internet and these computer systems, many types of attacks can be conducted over a network. Therefore, IPS and IDS systems are used in just about every network system. Ooh, okay, so how can we scan that with NMAP? How can I scan without getting caught within an IPS and IDS system? I'm glad you asked. It's time to learn about that. How to bypass IPS and IDS systems. Now, there are actually many ways to circumvent IPS and IDS systems when scanning with NMAP. And I'll list some of them. Timing, the most basic detection method of IPS and IDS systems. Blocked if one rope on the network attempts to access multiple ropes and scans on all ports. So in this case, all you need to do is scan individual threads and ports. And then don't access more than one IP and one port at the same time. So in other words, you'll disable parallel scanning. So to do this, it's necessary to scan with NMAP in either T0 or T1 mode. But do remember that T0 and T1 will take a much longer time to scan. Source port. So another method is to scan packets directly through a port with NMAP. We can make NMAP act as an HTTP service. Many IPS and IDS systems allow packets sent through port 80 to pass through. But NMAP must be used with the source port parameter. So let's do an example. Turn on virtual machines that we have installed. Open VirtualBox. Open Kali Linux 10.0.2.15. Open Ubuntu 10.0.2.7. Open Windows 7 10.0.2.6. Log into Kali Linux VMs. Username root, password tour, and open terminal. And then write this command. NMAP 10.0.2.6, source port 80, press enter, and there are your scan results. Randomized scanning order. So another method is to randomly select the hosts to be scanned. NMAP will scan the threads in sequence when used in default or normal scanning. So in this case, the safety systems may interfere with the thread on which NMAP is installed. So in order to prevent this, we can provide random selection of strings to be scanned with NMAP. So for random scanning, we can use the randomize host parameter with NMAP. And I'll give you that example. If you turn on the virtual machines we have installed, open VirtualBox, open Kali Linux 10.0.2.15, open Ubuntu 10.0.2.7, open Windows 7 10.0.2.6, open Metasploitable 10.0.2.4, and log into Kali Linux VMs. Username root, password tour, open terminal, and write this command. NMAP 10.0.2.0/24, randomize hosts, press enter, and the scan results follow. So as you can see, it didn't scan in any order. It randomly scanned all of the IP addresses. MAC address spoofing. So another method of bypassing firewall restrictions when port scanning is to emulate the MAC address of another computer. This technique can be very effective, especially if there is a MAC filtering rule that only allows traffic from certain MAC addresses. So you will need to discover which MAC address you need to set in order to get the correct results. So specifically, the spoof MAC option allows you to select a MAC address from a specific vendor, select a random MAC address, or set a specific MAC address of your choice. Another advantage of MAC address fraud is that you make your browsing more confidential because your actual MAC address does not appear in the firewall log files. Command. Specify MAC address from a vendor, NMAP, spoof MAC, Dell, /Apple/3Com IP target. Generate a random MAC address, NMAP, spoof MAC 0 IP target. Specify your own MAC address, NMAP, spoof MAC 0A0027000006 IP target. And here's an example. Turn on the virtual machines that we have installed. Open VirtualBox. Open Kali Linux 10.0.2.15. Open Metasploitable 10.0.2.4. Log into Kali Linux VMs, username root, password tour, and open terminal. And then write this command. NMAP stpn spoof Mac 3com 10.0.2.4, press enter. And the scan results follow. So NMAP generated the MAC address of 3com and scanned it using this MAC address. Now, to change the IPv4 lifetime, or MTU value, in sent packets, so NMAP gives the user the option to set a specific MTU, which is the maximum transmission unit, to the package. So it's similar to the packet fragmentation technique. During scanning, NMAP will create packets based on the number of MTUs we provide. For example, if we set the MTU to 16, NMAP will generate packets of 16 bytes and cause confusion on the firewall. Now, please note, though, that the MTU value must be a multiple of 8. So 8, 16, 24, 32, etc. So here's an example. Turn on the virtual machines we have installed. Open VirtualBox. Open Kali Linux 10.0.2.15. Open Ubuntu 10.0.2.7. Log into Kali Linux VMs. Username root, password tour. Open terminal. And write this command. nmap mtu 16 10.0.2.7. Press enter. And the scan results follow. Send bad checksums is another way to circumvent security systems. Send incorrect checksum packets. Now, many security systems ignore faulty packets, especially due to performance problems. So by taking advantage of this incorrect behavior, we may be able to send incorrect checksum packets with NMAP. And you can use the NMAP bad sum target command to send packets to destinations that have failed checksum packets. So I'll show you an example. Turn on the virtual machines we have installed. Open VirtualBox, open Kali Linux 10.0.2.15. Open Ubuntu 10.0.2.7. Log into Kali Linux VMs. Username root, password tour. Open terminal and write this command. nmap bad sum 10.0.2.7. Press enter. And there are the scan results. Fragmentation. So yet another method is to shred the sent packets into smaller packets. To do this, we can use the F parameter in NMAP. For example, if you turn on the virtual machines we have installed, open VirtualBox, open Kali Linux 10.0.2.15, open Ubuntu 10.0.2.7. Log into Kali Linux VMs, username root, password tour, open terminal, and write this command, nmap f 10.0.2.7, press enter, and there are your scan results.